Welcome to another tutor short provided by the Educational Support Services Department at Lehigh Carbon Community College in Schnecksville, PA, just outside Allentown. These videos cover key concepts for math and other math-based courses here at L-Tri-C. Please remember that the Educational Support Services Department does provide walk-in tutoring 5 days a week in math and other subjects. This tutor short video will cover solving systems of equations. When you're solving systems of equations, there are 3 different methods that can be used. These are graphing, substitution, and elimination. We will also look at solving systems of inequalities by graphing at the end. To solve a system of equations by graphing, you first start by graphing each of the equations. Then you need to find the point where the lines intersect. There are 2 special cases when you're solving by graphing. The first is if you end up with parallel lines. These lines will never intersect, so the solution is there is no solution. The system has no solution, because the lines never meet. The second special case is when you have identical lines. The lines are the same thing, just written different ways. In this case, the solution is all real numbers because it works everywhere. Our first system is 4x plus 3y equals negative 24 and 3x minus y equals negative 5. I'm going to start with my first equation, and I'm going to graph this by using my intercepts. To find my x-intercept, I let y be 0. So it's going to be 4x plus 3 times 0 is 0 equals negative 24. Divide by 4. X equals negative 6. So my x-intercept is negative 6, 0. I can graph that point. Now I need to find my y-intercept. To find my y-intercept, I let x be 0. 4 times 0 is 0. I can ignore that. So I have 3y equals negative 24. Divide both sides by 3. Y equals negative 8. My y-intercept is 0, negative 8. And I plot that point on my y-axis. Now I have my 2 points, I can graph my line. So now I need to graph my second equation. 3x minus y equals negative 5. This time I'm going to use slope-intercept form. So my initial equation is 3x minus y equals negative 5. Subtract 3x from both sides. I get negative y equals negative 3x minus 5. Divide both sides by negative 1. And I get y equals 3x plus 5. My slope is 3, or 3 over 1. My y-intercept, or b, is 5. So my y-axis, I go to 5. My slope says rise 3, run 1. Or I can go, instead of rising 3, running to the right 1, I can go down 3 and run back 1. Graph my line through all my points. Here is my intersection. That is at the point negative 3, negative 4. So that is the solution to this system. Now in this case, for the red equation, I use my intercepts to graph, and for the blue equation, I use my slope-intercept form. It doesn't matter which method you use to graph it, you just need to make sure you graph it accurately. Next we have x plus y equals 2 and x plus y equals 5. I'm going to use slope-intercept form for both of these. X plus y equals 2. Subtract x from both sides. I get y equals negative x plus 2. So in this case, my m is negative 1. My b is 2. Start at 2 on the y-axis. Down 1 over 1. There's my line. For my second equation, x plus y equals 5. Subtract x from both sides. Y equals negative x plus 5. My slope is negative 1. My y-intercept is 5. Go to 5 on my y-axis. Down 1 over 1. There's my line. These lines are parallel. They are never going to meet. I can see this because they both have the same slope, or if I look at my graph, these aren't going to meet anywhere. Since these lines are never going to meet, the answer is no solution. This was one of our special cases. Our next method is solving systems of equations by substitution. You start by solving one equation for the first variable. It doesn't matter which one you pick. Typically we want to choose the easier one to get. Then we substitute that into the second equation to then solve for the second variable. Once we know what the second variable is, we can go back and figure out what the first variable was. Again, we have the same two special cases. We get an impossible solution, something like we end up with 6 equals 0, then we have no solution to our system. Or if we get a fact, like 4 equals 4, then the answer is all real numbers. When we graphed, this was our parallel lines, which are never going to meet, which is why we get something that's false. Or when we had the same line on top of itself, that's like getting 4 equals 4, because that's always true. So our first system for this example is 2x plus 5y equals 7 and x plus y equals negative 1. I can solve one of my equations for x or one of my equations for y. I'm going to solve my second equation for y. So I'm going to subtract x from both sides, and I get y equals negative x minus 1. So now that I know y equals negative x minus 1, I want to take this, and I'm going to plug it in for y into my first equation. So now I have 2x plus 5 instead of y, I now have negative x minus 1 equals 7. Use my distributive property, I get 2x plus negative 5x minus 5 equals 7. Combine my like terms on the same side of the equation. 2x plus negative 5x is negative 3x minus 5 equals 7. Add 5 to both sides. Negative 3x equals 12. Divide by negative 3. I get that x is negative 4. Now that I know what my first or my second variable is, I want to take this and plug it back in here to find out what my y is. So y is negative 4 minus 1. Negative 4 is just 4 minus 1, or y is 3. So if my x was negative 4 and my y is 3, the answer to this system is negative 4, 3. Our next example, 3x minus y equals 4, and negative 9x plus 3y equals negative 12. Again, I need to decide which variable do I want to solve for. I could pick x or I could pick y. I can pick either equation. I think this y looks like the easiest one to get by itself. So starting with 3x minus y equals 4. Subtract 3x from both sides. Those are going to cancel. I have negative y equals negative 3x plus 4. Divide by negative 1. Y equals 3x minus 4. So now I want to take this and substitute it in for my y in the second equation. So now I have negative 9x plus 3 times the quantity, 3x minus 4, because that's what y is equal to, equals negative 12. Distributive property, so we have negative 9x plus 9x minus 12 equals negative 12. Negative 9x plus 9x, combining my like terms on the same side of the equation, that's going to be 0x, so those cancel each other out. I'm left with negative 12 equals negative 12. This is a true fact. Negative 12 does equal negative 12. That is always true. So my answer is all real numbers. So any value of x will work in this. Our third method is by elimination. You want to manipulate your equations so that your variables and constants and equal signs all line up vertically. Then you want to adjust your equations so that one variable will cancel out. Then you add your equations together, solve for the first variable, and then use that to find the second. And once again, we still have the same two special cases that we did last time. If you get an impossible solution, it has no solution. If you get a fact solution, it's all real numbers. Our first example, y plus 11 equals 2x, and 5x equals y plus 26. I'm going to keep my first equation the same. My second equation, I have my y and my constant on one side, my x on the other, but they're on the wrong side of the equal sign, so I can just rewrite my equation and flip it over the equal sign. Y plus 26 equals 5x. All I did there was just rewrite it the other way around, so now everything lines up. My y's are above each other, my constants, my equal signs, my x's. So now I want to be able to add these together and have something cancel out. I have 2x and 5x, they're not going to cancel out easily. I have y and y, that can work quite nicely if I take one of my equations and multiply everything by negative 1. This is going to become negative y minus 11 equals negative 2x. Just multiplied everything by negative 1. I'm going to keep my second equation the same. Y plus 26 equals 5x. So now I want to add these two together. Negative y plus y makes 0. Those are going to cancel. That was the goal. Then we have negative 11 plus 26. That makes 15 equals negative 2x plus 5x makes 3x. Divide both sides by 3. And I get 5 equals x. So now I can take this and solve for y. So I'm going to take my 5. Let's use this equation. Y plus 26 equals 5 times 5. Y plus 26 equals 25. Subtract 26 from both sides, and I get y equals -1. So the solution to this system, my x was 5, my y is -1. Our next example, -2x plus 3y equals 4, 4x equals 6y plus 8. So I have to first get everything to line up properly. Again, I'm going to leave my first equation the same. This is going to be -2x plus 3y equals 4. If I look at my second equation, I have x's on the left side of the equation, y's and constants on the right side. I need to move my y over with my x's, so I'm going to subtract 6y from both sides. These will cancel. So now I have 4x minus 6y equals 8. Again, I have x's, y's, my equal sign, my constants. Everything's lined up vertically. So now I want to get things to cancel out when I add them together. If I look at my x's, I have -2x in the top, 4 in the bottom. To get those to cancel out, I'm going to take my top equation and multiply everything by 2. -2x becomes -4x, plus 3y times 2 is 6y, equals 4 times 2 is 8. My bottom equation, I'll just leave the same. 4x minus 6y equals 8. Add these together. -4x plus 4x, that's 0. 6y plus -6y, that's also 0. 8 plus 8 is 16, so I have 0 equals 16. All of my variables are gone. 0 does not equal 16. This is false. So this system has no solution. These are parallel lines, they never cross. So now we're going to move on to solving systems of inequalities by graphing. You first graph each inequality. Take note of which direction to shade for each inequality. Whichever area gets shaded by both inequalities will be your answer area. So our first inequality is x plus 2y is less than or equal to 10. I'll do this one in red. So I need to figure out, do I want to use my intercepts or slope-intercept form? I'm going to use my x and y intercepts to graph this inequality. So I'm going to pretend I have x plus 2y equals 10. It's just easier to start out that way. For my x-intercept, I let y be 0. So I have x plus 2 times 0 is 0. Don't really need that. So x equals 10. My x-intercept is 10, 0. I can plot that point. For my y-intercept, I let x be 0. So it would be 0 plus, don't really need that part, 2y equals 10. Divide by 2. I get y equals 5. So my y-intercept is 0, 5. Plot my point. Now I need to draw my line. Since this was less than or equal to in my initial inequality, since it's less than or equal to, the or equal to means I'm going to use a solid line. Now I need to test a point. I'm going to test my favorite point, 0, 0. 0 plus 2 times 0 is less than or equal to 10. 0 plus 2 times 0 is 0. is less than or equal to 10. That is a true statement, so I want to include the point 0, 0 in my shaded area. So I'm going to be shading under this line. I just like to put little arrows to tell me which way I should shade in the end. So now I need to graph my second inequality. This time I'll use blue. And again, I'm going to use my intercepts to do this. And I'm going to pretend this is 3x minus 6y equals 12. To find my x-intercept, I let my y's be 0. So it's 3x minus 6 times 0 is 0, that goes away, equals 12. Divide by 3. X equals 4, so my x-intercept is 4, 0. Y-intercept, I let x be 0. 3 times 0 is 0, goes away. Negative 6y equals 12. Divide by negative 6. I get y equals negative 2. So my y-intercept is 0, negative 2. Now this time, if I look at my initial inequality, I had greater than. There's no or equal to, so this is going to be a dashed line. Now I need to test a point. So 3 times 0 minus 6 times 0 is greater than 12. 3 times 0 is 0, 6 times 0 is 0, 0 minus 0 is 0, 0 is greater than 12. This is false, so I don't want to include this point. So I'm going to shade this way under my line. If I look, I have 4 areas on my graph. 1, 2, 3, 4. Because I have 2 lines that cross, I end up with 4 areas. The red line I'd be shading into areas 2 and 3. The blue line I'd be shading into areas 3 and 4. What's common between them is area 3. That is my solution area. Our last example, 3x minus y is greater than or equal to negative 9, and x plus y is less than 4. So for my first one, 3x minus y is greater than or equal to negative 9. I'm going to pretend that's 3x minus y equals negative 9. I'm going to put this into slope-intercept form. So I can subtract 3x from both sides. Negative y equals negative 3x minus 9. Divide both sides by negative 1. I get y equals 3x plus 9. My slope is 3, or 3 over 1. My b is 9. So my y-intercept's 9. My slope says rise 3, run 1. Can't really go any higher on this graph, but I can go down 3, back 1. Down 3, back 1, down 3, back 1, again and again and again. Looking at my initial inequality, greater than or equal to means straight line. I'm going to test 0, 0. I always like to test 0, 0 unless the line goes through that point, because it's normally easy to test. 3 times 0 minus 0 is greater than or equal to negative 9. 3 times 0 is 0, minus 0 is 0. 0 is greater than or equal to negative 9. That is true. My point 0, 0 is here. I want to shade on that side of the line. So again, I make my little arrows to remind myself. Second inequality, x plus 4 is, or x plus y is less than 4. Again, I'm going to put this into slope-intercept form. We did intercepts on the first example. We'll do slope-intercept form this time. It doesn't matter which method you use, just so long as you get it graphed. And again, I'm going to pretend I have an equal sign. Subtract x from both sides. I get y equals negative x plus 4. My m, or my slope, is negative 1. My b is 4. 4 on the y-axis. Slope of negative 1 means down 1 over 1. Or back 1, up 1. My inequality was less than, so that means I'm going to use a dashed line. Test a point. Again, I'm going to choose 0, 0. Is 0 plus 0 less than 4? 0 less than 4. That is true. So I'm going to shade the side that has the point 0, 0. Shading this way. Looking for which of the 4 areas gets shaded by both lines, and that would be that area.